Good morning. Let's try that again. Good morning. All right, excellent. Well, it's a great pleasure to be here to talk about something we all deal with every single day. But a quick show of hands, how many of you are developing software? I want to make sure I'm in the right place. Excellent, thank you. One of the things we deal with every single day that you go to work is complexity. There are some people who will take concepts, ideas, and they'll take even simple things, and they'll make it complicated. And this is a fight we have to put up with every single day that we live in. So what I want to talk about is, how could we possibly move in the opposite direction? How can we make things simple? And that's what I want to focus on today. Well, in this room, we have several of the most complicated systems ever known to humans. That's the beautiful human brain. And the human brain is probably the one we have least understood. And I'm sure you deal with this every day, whether it's a small child that you have at home or a more complicated human being that you work with. And we often ask the question, how do you think of that? And how do you come up with this idea? And we have these bursts of ideas that seem to come from nowhere we know. And yet, it's the same human mind, which is so creative, is also the one that gets tangled up in emotions, in analysis paralysis. And we just get stuck with our ideas, not able to move forward. And that's the beauty of what we live with every day. Something as creative and yet so stuck in the ways, and we have to deal with that every day. Well, my children are grown today, but when they were young, we used to talk a lot about different stuff. But one of the things my children grew up with is talking about Schrodinger's cat. And Schrodinger had this thought experiment about a particular chamber where you cannot see through it. There's a cat stuck in it. There's a vial in that which may spill and kill the cat. So the question is the cat, alive or dead? Well, we keep talking about Schrodinger's cat quite a bit, and his concept is maybe at the same time the cat is dead or alive. How do you reason that? But we'll come to that thought later on. But let's talk about simplicity. Well, as Confucius said, life is really simple, but we insist on making it complicated. We just love to make things complicated. That is just us. But the question I want to ask is, why? Why do we like to make things complicated? You have a design, you take it to your colleague, and you say, here you go, this is the design I came with. And your colleague looks at it and says, yeah, I understand it. That looks simple. And you feel a little let down. You're like, give it to me. I'll come back tomorrow. And we make it more complicated. Now we give it to them, and they are like scratching their head. I don't understand it. It works, but I don't know why. And we feel really good about it, right? So why do we feel good about creating complicated things? There is an underpinning reason, I think. When you create something really complex, you feel proud about it, isn't it? That proverbial hand comes and pats you in the back. You're awesome. Look at what you created. If you hire interns from the university and they come and work with you during the summer, if they go back to college, don't send them alone. Go back with them and hear what they are saying. They probably tell their colleagues at school, the company I worked with, they're amazing. I have no clue what they're doing. So we feel good about making things complex. We feel good about creating things that are hard to work with. Because somehow, in a wrong way, we associate our worthiness to complicated things we create, which is very misguided. But I think we should try really hard to go the other way. As Einstein said, any intelligent fool can make things bigger, more complex, and more violent. It takes a touch of genius, and a lot of courage to move in the opposite direction. And I want to point you to one word that is in a saying that is probably the most important word. And that word that is the most important is not the word genius, no. It's the word courage. And that is one of the things we need, is the courage to stand up among our colleagues and say, nope, I am not going to make it complicated. No, I'm going to work towards making it simple. And it does really take that courage to say that we don't have to clutter things up. We don't have to make things more complex. We can actually make things simple and maintainable, but we have to put that fight up every day to make things simple. Because the human nature is to go in the opposite direction. Our colleagues want to clutter, make things complex. And sometimes complexity makes money, unfortunately. But we have to work really hard to go in the opposite direction. But one of the problems really is, imagine you are sitting in a train or a bus, or even here. If simple was sitting next to you, will you identify it? Would you say, oh, you're simple, isn't it? One of the biggest problems is it's really hard for us to know what simple really is. I bet you nobody wakes up in the morning and thinks, I really want to go to work and make things complex. That's not in our mind. The problem is, the reason why we make things complex is we don't even realize what simple is. This reminds me of an experience I had. I was consulting with a team of developers, and I was telling them their code is complex. And I was mentioning this several times, and the team leader came to me and said, hey, Venkat, I was talking to my team a few minutes ago, and they are all kind of wondering why you keep saying our code is complex. Because I asked every one of them, and we all collectively feel our code is simple. And you keep saying it's complex. Why? And I was quite baffled that the team entirely will think the code is simple while I keep thinking it's complex. So I said, oh, excuse me, but can you tell me why you think the code is simple? And he said, sure. And he opens up the code I was complaining about and said, look at it. All we have is a very simple if statement. There's if and else. There's nothing complex about it. And I said, oh, I get it. I see why you say it is simple. The problem is not that you have an if and else. The problem is you have 60 of them in the same function. And you have 60 levels of nesting. And how do you maintain that code? And that code is duplicated in so many places. So that's where the complexity really came from. So oftentimes we don't even know what complexity versus simplicity is, and that makes it really hard oftentimes. So if simplicity was sitting next to us, how do we even know it? So we want to be able to identify simplicity. But as it turns out, that's not really easy. So I'm going to go the opposite direction. I'm going to show you what is not simple. Maybe if we find out what is not simple, and when you look at it, you say, hey, that's not simple, maybe we should go in the opposite direction, right? So let's talk about what is not simple. And we can recognize these in our own work, in our own daily efforts. So what is not simple? The first is, simple is not clever. Let's be honest about it. Raise your hand if you have ever written clever code. Come on. Raise your hand if you've ever written clever code. Have you ever written code? Do you write code? That's it? Earlier you said you develop software. Who writes code here? That's it? Only 20 people write code? Nobody else writes code? Seriously? Okay, let me try something else. Who will raise the hand if I ask you to raise the hand? Who will not raise the hand if I ask you to raise the hand? He's raising the hand still. Wow, this is a tough crowd. Let's stand up. Let's stand up. Let's warm up. Because this crowd is not interactive. Let's get up. Thank you. He's even running away. All right, let's warm up. Let's shake our hands. Oh, yeah, let's warm up, right? It's Saturday, I understand. Let's sit down. All right. So, let's warm up a little bit. We're here to interact. We're here to learn from each other, right? So let's warm up. I know it's a sleepy Saturday morning, right? I forgot that. Excellent. So, everyone who writes code has written clever code, right? Well, why do we write clever code? Because deep down, it feels good to write clever code. You write a piece of code, and your colleague says, wow, that's a very interesting way to solve the problem. And we are like, yeah, that was good, isn't it? I'll tell you my own experience. A client of mine said, we got a problem in production, we need to fix it. And I looked at the problem, and I said, it's a 10-minute solution. I know exactly what to change, and it'll work. But no, I don't want to do that. I don't want to solve the problem. I want to solve the mother of all problems. I'm going to analyze the pattern of these problems. And I'm going to solve not just the problem, but any recurring problem ever into the future. And I solved the problem, and I felt so good about it. I'm like, this is awesome. I fixed it, but a problem like this will never happen. Well, 3 weeks went by. I got a conversation in the client side. They have a very serious problem in production. And I looked at it and immediately sent a message to them saying, I'm on it, I'm going to fix it. And they said, oh, we know you'll fix it because you're really good. And I replied to them saying, no, I'm not going to fix it because I'm good. I'm going to fix it because I'm the one who caused it. Remember that clever solution? It had backfired in ways I never understood, I never thought about. And I went back, removed the code I changed, and put that 10-minute solution. And it never failed again. And a lesson I learned the hard way. These days when I sit and write code, my little brain says, oh, that's clever. I immediately delete the code and I start over. Because clever solutions are not maintainable. Clever solutions come back to bite us in the back. So I'm sure everyone has looked at that, right, before? Let's take a look. Abstract class enum, E extends enum E. You're defining enum using enum. Oh, that noise you just heard? That is your brain throwing an exception at you. You're like, what does this mean? That is one example of a very complex piece of code. How do you reason with a code like this? How do you understand and maintain a code like this? Now, of course, when I go to clients, often they tell me, how do we obfuscate code, they ask me. Well, I came across this code. I often tell them, you don't need to obfuscate your code. Your programmers naturally write self-obfuscated code. They don't even understand the code they're writing once they finish writing it. Because we all write so complex, hard to maintain code, isn't it? I came across this code. Notice it says float x. I don't know what x is. But here's the good news. Whatever x is, we have half of it. And then don't tell me you don't know what that means, right? That's a beautiful bit manipulation. But here's the beauty. It doesn't matter what x is, whatever it is, we return it in the end. How do you reason with the code like this? If you give this code to somebody and say, maintain it, how do they understand this code and how do they maintain this code? That becomes incredibly difficult, isn't it? Well, remember how they said to us that object-oriented code, or code in general, models the real world? Well, somebody took that to the really bad extent, and they wanted to work on a flight simulator. So they wrote this code. My question is, where were the adults when they were writing this code? You want to say, excuse me, we don't do that around here. We need to write code that's easier to understand, easier to maintain, isn't it? And imagine you get a code like this and you have to maintain this. How do you deal with it? So this is a very clever code, as you can see, right? So no, we don't want to write clever code. Clever code, a simple code is not clever. Simple code is not necessarily familiar. Now, this is one of the problems we have to deal with every day. And that is, this is human nature. We confuse familiar with simple. We do this all the time. So when people look at the code and ask me and say, ooh, that code is complex, or that code is simple, I often ask them, hang on. Are you saying the code is complex? Or are you saying you are unfamiliar with it? Or are you saying this code is simple? Or are you saying I am familiar with it? So this is unfortunate, but it's true. Familiar, often feels simple, even when it is not. So you look at a code, and you're like, I've seen this a million times. So when you look at it, you don't feel the pain. The reason you don't feel the pain is you're very familiar with it. But unfortunately, though, it's also true that unfamiliar often feels complex. Usually it is, even when it is not. So this is the problem we have to deal with every single day. So I often ask the question, not whether it's complex or simple. The question is it familiar or unfamiliar? If something is unfamiliar, we have no right to judge on the quality of simplicity versus complexity. Because what is unfamiliar to you is going to be strange. And that's in our DNA as human beings. We fear things that are unfamiliar to us because that may be a threat to us. That's natural. So we need to really ask the question, are we familiar with it first before we can make the decision towards it? That is something we have to work with. If I ask you, what's that? Well, it depends on where you ask that question. And if you ask a population which doesn't understand the language, they're going to say, gosh, does look complex. So I looked up, and they said it is actually simple and complicated, casual, common. But how do you evaluate that if you're not familiar with something? That's a question you want to ask. Let's take a simple problem, right? So here's a simple problem. So let's say, given a bunch of names, let's say create a string, comma separated, of names in uppercase, of length, let's say 5. That's a simple problem, isn't it? So given a bunch of names, create me a string, comma separated, with names in uppercase, of length 5. So let's start with names equal to, let's create some names over here. So here's a bunch of names I want to start with. So what am I going to do? I could say for, you could say name coming from, well actually, you could do this, right? I equal to 0, you could start with that. I less than, names dot, is it length? Size? What is it? That is, if there was a standard, we would know it, right? But standard is simple. We can't do that. We'll keep inventing new names. So there's no standard, isn't it? Well, of course, in Java, you know it's going to be size. Then you say, after that, you could say, size, and I plus plus. Or is it plus plus I? Which one should we do? And then you say, oh, but wait, question again. Is it less than or less than or equal to? How many times have you wondered it? You write the code, is it less than or less than or equal to? We don't know, right? Because every time you write the code, you have to pause and think, do I stop here? Is it less than or less than or equal to? Have you ever wondered about it? Every single time. So somebody asked me, what is the symbol? What is that symbol? I say that it is the international symbol for I feel stupid. So essentially, that's what it really is. Because every time you write that, you got to ask the question, is it less than or less than or equal to? That is complexity. It keeps you away from solving your problem because you're worried you're going to make a mistake, isn't it? But here's the good news, you know this, right? The good news is you don't have to struggle that hard, somebody says. There's a simple solution. Really, what is it? For, you can say a name, coming from names, and what are we going to do here? You could say if the name is dot length, right, is equal to 5, because that's what we want, length of 5, we can say output name dot to uppercase. So we can write the code like that, isn't it? To get the names in uppercase. You say, yeah, but we don't want that in uppercase. We want comma separated. Oh, no problem. Plus comma, right? You can put a comma to it, right? And they say, no, but we want them on the same line. Okay, great, we can put them on the same line. And then you say, wait, have you ever had this problem? There's a stupid comma in the end. Have you had that problem before? You write that code and you're like, how do I get rid of that comma in the end? And now you're staring at the code. In the meantime, your boss says, are you done yet? And you're like, shut up. I'm trying to get rid of the comma right now. And you're not sure. And then you say, maybe I can put this into a string buffer and remove it from the end. And your colleague says, did you mean string buffer? Or did you mean string builder? Now we are having a discussion. String buffer was a string builder. In the meantime, I saw a product owner here. He's like, excuse me, my deadline. Have you finished my code yet? Can I release it to the customers? You don't understand software development. We got to figure out how to get rid of the stupid comma. What is that called? That is called accidental. Accidental complexity. So what is accidental complexity? Accidental complexity comes from solution that you use. It doesn't come from the problem space. It comes from the solution space. So you have domain-specific complexity. But this is accidental complexity. We're like, how do we deal with this? How do we remove that comma in the end? And somebody says, I've got an idea for you. Start with the for int I equal to 0. And here we go again, full circle. How do we solve this, right? So this is complexity we have to deal with. Or you say, maybe there's a better way to do this. So you could say, for example, result is equal to, and I want to output the result in the very end. But what am I going to do here? Names.stream, maybe, a filter given a name.length is equal to 5, and then we can do a map of a string, in this case, to an uppercase. So we could say to uppercase. And then you could say collect. Maybe we can simply say joining using a comma in this case. And so this comes from the Java's collectors. We could bring it in. So here is the collectors. And so as a result, we don't have to deal with the stupid comma in the end. And when you look at this, what's a benefit? So all of a sudden, the code reads like the problem statement. So essentially, you removed the accidental complexity. So essentially, the question we want to ask really is, how can we write simple code? So for a lot of us, The functional way of doing things is unfamiliar. And I've had so many people tell me, oh my gosh, that's complex. But why do we feel it's complex? Because it's unfamiliar. So what we notice is the for loop is very familiar, but highly complex. So we look at it and say, yeah, we're used to it. We've done it a million times, but it's actually complex. Functional iteration is very unfamiliar, but highly simple. So how do we deal with these differences? Something is simple, but unfamiliar. Something is complex, but we stick to it. Why? Because it's so familiar. I'm used to it, and we have to break away. So, in other words, we have to make the unfamiliar ultimately familiar. We have no hope otherwise. If we don't make it familiar, it'll always keep us away from trying the simple things. And that's why we are professionals. We got to constantly keep learning about ways to do things. So we often confuse familiar with simple. And once you recognize it, you know to fight that battle and say, nope, I'm not going to be cheated by familiarity. I need to focus on whether it's truly simple or not. So a lot of us are familiar with imperative style, but declarative is simple. Why? Because simple has fewer moving parts in it. I'm going to paraphrase Michael Feathers. This is a beautiful quote. And Michael Feathers said this once. He said, in OOP, we encapsulate the moving parts. He said, in functional programming, we eliminate the moving parts. What a beautiful, beautiful line of thinking, isn't it? In object-oriented programming, we encapsulate the moving parts. Things that keep wobbling and changing, right? What do? You encapsulate it. And you say, no, you cannot see it. We're going to protect its change. But it's still there. The root cause is there. You're just putting more things around it so it hurts you less. In functional programming, we eliminate the moving parts. You're like, get rid of it. Because what you don't have to deal with hurts you less. So get rid of it rather than encapsulating it. That can lead to better, easier to maintain code, and that becomes a lot easier to work with. And this is something we need to really strive in terms of dealing with complexity in general. So I said simple is not clever. Simple is not necessarily familiar. Simple is not over-engineered. Over-engineering, we do this all the time. We all love creating the Rube Goldberg machines. Rube Goldberg was a guy who talked about absolutely ridiculous complex solutions. And he has drawn several of those, as one of these where the water is poured on the old man who pulls that umbrella, which draws those pulley, and eventually it scratches this guy's back. And it, like, you look at this and say, that's ridiculous. But honestly, we all have written that code in our projects, isn't it? Your colleague looks at your code and is scratching your head. Wow. I was once looking at a piece of code. This programmer had taken the data from this database table, 250 lines of code for creating XML document, and then takes the XML document, sends it to this other function. The function, another 200 lines of code to parse the XML document, and then does a little transformation of the data and puts it back into the database. My head is spinning. I'm looking at this code. Wait, data to XML, XML to data. Like, why? I went to the developer and said, hey, I'm looking at your code. You're taking this data and you're creating XML. He said, isn't that cool? No. I don't think I would use the word cool for that. Why? And he said, the code is extensible. I said, extensible? Extensible for what? He said, the data can come from anywhere, and the data can go anywhere. I said, hang on. In this application, where does the data come from? That table. Where does it go to? That table. Then why do you want the data to come from anywhere? You just want to take the data from here to here, isn't it? Oh, Venkat, you don't have a vision. I don't have a vision. I have a requirement. Oh, you should have vision. So I fiddled with my phone, and I was, hello. He said, hang on a second, I got a call. So he picks up the phone, hello. Hey, how's it going? Who is this? Oh, I just want to check on you, how are things? Wait, is that you, Venkat? I said, yeah. Why in the world are you calling me on the phone when you're right in front of me? I said, you need to have a vision. You could be anywhere. I could be anywhere. And we can still talk, isn't it? So we should never talk directly. We should always use the phone to talk. It's like, that's stupid. Exactly. So why are we complicating code for no good reason? And here is the problem we have to deal with every single day. So the problem we have to deal with every single day is this. Extensibility is a slippery slope. We all tell ourselves, make the code extensible, make the code extensible. You know what the problem is? We have no clue what extensible means. Yet we are chanting, make the code extensible. And here's the problem. Extensibility needs really good anticipation. If we anticipate really well, we get extensibility. On the other hand, if we anticipate poorly, we get, unfortunately, unnecessary complexity. So this is the problem we have to deal with. You got to be really good in anticipating. How many of us are good in anticipating? Very few of us. So in the name of extensibility, we create complexity. That's what we do. That's one of the myths we strive for. We don't know what we are building, so let's build for the future. And in the process, we build something enormously complex, enormously hard to maintain. That becomes really hard. Simple is not terse. I came across this code. I was working for a client down in Texas, and I was looking at several code with the programmer. He opened a file, moved away. I said, excuse me, can you just go to this other file? I thought I saw something. Sure. He goes to the file. And I'm staring at that. And I said, do you mind if I take a photo? And he said, remember the NDA? I said, I will never tell who you are. Promise. Okay, you can take a photo. And I took a photo. Oh, what I took a photo was not that line. It was the line below that line. Literally in production code, I saw this. It said, God help me. I have no idea what this means. This was the code that was sitting right there in production code. And I looked at it and said, no, somebody wrote that comment. Like, yeah. You guys didn't even remove it. He's like, yeah, out of respect for the person who wrote it. Not the code, but the comment. But how many times have we seen code like that, where the names of the variables don't represent anything meaningful for us to know? So it's extremely hard to maintain code like that. That becomes really, really hard to work with. And that becomes really time-consuming. And it costs us more money and more time. And in the meantime, the clients are waiting for the product we are building, isn't it? That's very hard. We look at a code like this and say, ooh, that is verbose, too many lines of code. You can look at a code like this, yay, it's concise. But is it concise? Turns out not, because this test will pass even if the wrong method throws an exception. You want to really strive towards conciseness, you may have to move in the opposite direction. Again, I would say, so what is terse? Terse code is short and waits to hurt us. Concise code is also short, but easy to understand and maintain. So don't, I would say, don't confuse terse with concise. We often don't distinguish the two, but can be really hard. We need to understand if a piece of code is really concise or a piece of code is terse. Because oftentimes it could be cryptic, hard to understand, hard to maintain. So you want to make sure this actually is easier to understand, easier to maintain, and short as well. We don't want terse code. That's horrible to maintain terse code. That's not useful. We want concise code because that's easier to maintain over time. If you tell me you got a choice between terse or verbose, thank you, I'll take verbose code any day rather than a terse code, because fewer lines of code is not what you really want in general. So don't confuse terse with concise and simple. Tony Herr said there are two ways of constructing a software design. One is to make it so simple that there are obviously no deficiencies. And the other is to make it so complicated that there are no obvious deficiencies. You don't even know what's broken in a piece of code. It is so complex. We can't even understand where to begin to find problems in the code. That becomes really hard. So you want to always think about how can we reduce that complexity in the code that becomes necessary. You say, all right, you told us what's not simple, but wouldn't it be nice to know a few things about what is simple? So let's take a look at an example of a few things. Simple keeps us focused. What is the most expensive thing in this world? The most expensive thing in this world is time. And you have given your time, and I respect that. The next most hard thing to have is your attention. Because if you live in the world, every few minutes, we got to pull the device, and we got to check the social media, isn't it? Getting people's attention is so hard. If your code can keep somebody's focus so they can understand, if your environment, your tool can keep somebody's focus, that's a big win. Let's think about it. You're working on a piece of code, you're typing away, and you're like, what's the function I should use for this? I don't remember. Let's be honest. What do if you don't know what you're doing? You're going to search, isn't it? Because if you spend 3 hours finding something that's the first on the search, that was not a good use of your time, right? So you're going to search. So let's search, can we? So let's go search. I'm going to search, what search engine should I use? Let's use Yahoo. How about that? So I go to Yahoo. The minute I go to Yahoo, ooh, look at that. Wow, a raccoon. I'm curious. Raccoons can have hiccups? Did you know that? That's funny. That's interesting. What else do we have? And you can kind of skip, ooh, I love dogs. Let's see what it says about this dog. Notice what happened. You wanted to know about this Java API. Now you're searching about raccoons and about dogs. Don't get me wrong, those are beautiful things. But you got completely distracted, isn't it? And then 20 minutes later, oh, what was the Java API? That is not a good idea, isn't it? Because when you go to search, you got distracted. I don't use Yahoo Search for that reason. Let's try one more time, can we? Let's Bing it. Whoa, did you see that beautiful bird? I kind of wonder what that bird is. It's so cute. And where is this photo taken? Maybe I can search for it. What if it shows me another picture? I may be distracted by that too. Let's try one more time, can we? Let's Google for it. That's Google. Now think about this for a minute. It says, why are you here? To search a Java API? What are you waiting for? There's nothing. Can you imagine this? Close your eyes for a minute and imagine this. The day in Google's office, a design engineer says, I've created the search page. And the boss says, let's look at it. Here you go. And they're like, what else? That's it. In fact, I know you're going to question it. That's why I have this, I'm feeling lucky. You should feel lucky to have your job. Honestly, how many of us, very honestly, how many of us will have the courage to do this? That's courage. Would you agree? For you to say, that's it. I am not going to distract people. How many of us use Google? You know why? You value your own time. You value your time. That's the most precious. If you don't value your time, it doesn't matter. By the way, I don't work for Google. I just want to make that upfront clear. I'm not getting any commission from them for saying it. I appreciate good things when I see them. And a few years ago, some of you may remember it, one day, people went to Google, and suddenly, there was a background picture. Remember that day? There was a huge amount of hue and cry on the web. They said, oh, Google has jumped the shark. It's gone down the drain. That's because they started putting background pictures. And immediately, they made the change to the configuration. The default, there's no pictures. But you can change your configuration and put pictures if you want to. Obviously, I won't. Because if I want pictures, I will Google for pictures. I don't want to be distracted by pictures, right? So the point really is to keep one's focus. That is a great design. That's what we need to strive for in our own experience. As Antonio Exupery says, perfection is achieved not when there is nothing more to add, but when there is nothing left to take away. What a beautiful way of thinking. I had a person come to me and said, could you please review my resume? I said, I'll be happy to. So he gives me his resume, a few pages long, and I said, hey, I know somebody who wants to hire a programmer who programs in C. Would you like to apply for the job? Heck no. Why is then C programming listed in your resume? Oh. And we started going through it, and his resume came down to 3/4 of a page from being multiple pages. But this 3/4 of the page was telling about him. Not about the world out there, but telling about him. What his interests are. Why should I hire him? And he's then sent me this quote and said, thank you. I did not realize, when I came to you, I thought, you're going to expand my resume. What you did instead is you reduced my resume. This is what I tell my clients. When I go to my clients, when I leave the building, they don't have more code. They have less code than when I go in. Because I'm the guy who keeps asking, why do we do that? Why do we need that? Why are we doing this? Reduce, reduce, reduce. Minimalism. I follow minimalistic design. And I love keeping things minimalistic. So simple eliminates accidental complexity and hides inherent complexity. So simple will eliminate accidental complexity. You're saying, no, that's too complex. It's not needed to solve the problem. Get rid of it. And we work towards making things simple. That's our job, is to make it less complex. Simple fails less, and simple fails gracefully. Things fail, isn't it? I'll never, ever, ever forget this experience. I had worked throughout the day. I know this is bad. Throughout the night. I've not slept for 40 hours. But I quickly had to go home, shower, and come back to work. So I'm driving home, very sleepy. And my car had almost no fuel. So pulled up by the gas station so I can fill up the gas. And I take the nozzle. I'm like sleepy, trying to put the gas, and it wouldn't fit. And I'm telling Venkat, you're so sleepy, you don't even know how to fill gas. And I'm like, why wouldn't it fit? Okay, calm down. Let me think about it. And I take the nozzle, see where it's going. It's a diesel. Can you imagine filling a petrol car with a diesel? These people are brilliant. If you have not tried it, I challenge you to try it one day. When you go to the gas station, don't take the petrol, but take the diesel and try to fill it in. The nozzle will not fit. You cannot put a diesel nozzle into a gasoline petrol tank. I was saying this in a conference a few months ago, and a guy sitting right where you are raised the hand. I said, yes. He said, I wish my sister gave up at that point. I said, what do you mean? Well, she's the one who doesn't take no for an answer. She got a funnel and filled it still. Go figure. You cannot really make a foolproof system, right? But the point is, that's a great design. It fails less. I didn't say it never fails. There's always a family member who will prove that you can still make it fail. But it fails less. So if I ask you, why is the cover like this? You could say, oh, I can give you a lot of reasons why the cover is like that. One of the reasons you may say the cover is like that is that it fits really well, and it's easy for somebody to go in and come out. But if I ask you to just create a design that just literally fits, you're going to probably create so many other designs, and every one of them will meet the criteria. And you may say, more complex designs make more money, right? But the benefit this has is, it doesn't matter how you roll it. At the end of a long day, if your crew is coming out of that hole, you're like, roll the damn thing, let's go home. You don't want to say, let me fit that in. So the circle fits the same in every direction. Simplicity. It doesn't also fall in. That's great as well. So simple is easier to understand and easier to work with. So for example, you can look at a code like this, where I'm saying primes, and I'm going to get all the primes by iterating over the primes. I know this is unfamiliar, but notice the simplicity if you're able to create an infinite series like that. But this takes me to something else that I ran into, and that is simple is elegant. Simple is elegant. Why is this one of the most famous paintings in the world? And the reason is no clutter. She has nothing to distract. No unnecessary jewelry, no unnecessary ornaments. She's got one thing, that beautiful smile. That's it. This is the most precious painting because it's the most simple. That's the touch of genius that Einstein was talking about as well. But to give you an example of this, I was in Boston. If you go to downtown Boston, I recommend you try this. I was in Boston. I was walking around with my family, and I came across this particular church, which is called the Trinity Church. And you may look at this and say, okay, Venkat, that's a church building, but it doesn't seem that exciting. Have you been around this country? There's more beautiful buildings. I respect that. But I was mesmerized. I kept staring. My family said, if you don't move, I'll call the cops on you, right? So you may say, what was so attractive to you? Honestly, not the church. Next to this church is a very tall building. It's called the John Hancock Building. And when they wanted to build this high-rise, they applied to the city and said, could we please build this here? And the city said, no. Like, why not? Because there's a beautiful church next to it. If you build something here, it'll take away the beauty of the church. And the architect said, no. I'm going to build it, and when I'm done, the beauty of the church will only be better. And he got the approval. So what was his simple design? And the simple design was, the building was structured in such a way, honestly, the reflection of the church on the building was so beautiful. I kept staring, not at the church, with all respect, but at the reflection of the church. I was like, wow, it is so beautiful. Church, it's okay, but the reflection, it is beautiful. That is a very simple design, and yet it served the purpose, which is to get the approval to say, when you're done building it, the beauty of the church will become no less in building it. That, again, is an amazing work, isn't it? But simple has to evolve. You cannot just sit there and say, all right, let's create simple. Boom, we are done. Not going to happen. It's got to evolve. I was working on a book, and I'll talk about that in a minute, but Richard Feynman said, if you cannot explain something to a first-year student, then you haven't really understood it. This has been my experience. If you cannot explain something, you haven't understood it. So, Occam's razor says, if you have two equally likely solutions to a problem, choose the simplest of them. So I was writing the book, Functional Programming in Java. And as I was writing this book, I really wanted to show how to do tail call optimization. You know why? Because Java doesn't have tail call optimization. So I said, oh, what if I can show how to do tail call optimization, which you cannot do in Java? I recommend not to ever do this in the middle of writing a book, trying to do something that's not possible to do in a language. But I told myself, aha, but if I have a factorial, for example, if I can call recursively, it'll be a Stack Overflow error because of the huge size, but tail call will be great. And I've read really good books, like Structure and Interpretation of Computer Programs. I've seen how tail call optimization is done in Clojure, Scala, Groovy, languages like that. Hey, if they can do it, why can't we do it, right? Usually a bad idea, and so in the middle of writing the book, I decided to implement tail call optimization. And right there, factorial, notice it's a tail call I'm going to make. And I wrote this code, and I put 20 hours into it, and then I put 10 more hours into it, and then I wrote this code, and notice a while call is not complete, current equal to current.apply. Except there was one problem. And the problem was, notice that line, current equal to current.apply. What is that? Mutability. And because it's a programming book on functional programming, until the previous page, I kept telling the reader, don't mutate, don't mutate, don't mutate. On that page, I'm mutating it. What do you do about a solution like this? I came up with what I think is the greatest solution ever. I put a footnote. Dear reader, do you notice I'm using mutation here? To convert this code into non-mutable code is left as an exercise to the reader. This would have worked 40 years ago, right? Awesome. But not in today's world of social media. Somebody is tweeting, hey, dude, how do you make this code immutable, huh? That won't work. Then I changed the footnote. Dear reader, Notice I'm using mutability. Don't use mutability if you can avoid it, but there are places you cannot avoid it. Bam. And I finally realized one grim truth, and that is, my code simply sucks. And I said, put it away, I'll think about it. And I was on the treadmill a few days ago jogging, and my thought was kind of thinking about this code, and suddenly I realized, oh my gosh, in the previous chapter I talked about how to really use lazy evaluation. Ta-da! I can use lazy evaluation and solve this problem. So I ran over to my desk, modified the code, and I said, start iterating using a streams iterate function, and go on until the first complete, find first get, that's lazy evaluation. It'll stop on first arrival of the result, and there was no mutability in code. I just fizzled to something that works. That only took me 4 or 5 days to figure out, and on a treadmill, away from the computer, that is. The point is, we have to take the time to evolve the solution. As Einstein says again, everything should be made as simple as possible, but not simpler. But how do we know? I take pride in my code is simple. I ask him to look at my code, and he says, oh, you can make it simple. Like, really? I made it simple already. He's like, no, let me show you how. So my code was simple a minute ago before he saw it. And the minute he saw it, the code that was simple is now complex because he realized it can be simpler. I like that kind of feedback, right? When a revelation happens on the code, such music is great to have as a feedback. So the question is it simple or can it be simpler? What's the answer? What if it's both? It is simple, but it can be simpler. So I think simple is like Schrödinger's cat. Your code is both simple and complex at the same time. It is simple to your eyes, but it's complex to somebody else's eyes. And they're going to help you to make it simpler. And it's an iterative, incremental journey we have to keep going over every step of the way. So don't get complacent. Don't assume your code is simple and you're done. It's good to strive towards making it simple. So simple makes things easy, but it's certainly not easy to make things simple. It actually takes a lot more effort to make things simple. It's easy to write complex code and walk away. You have to work really hard to make things simple, and it takes time as well. As Da Vinci said, simplicity is the ultimate sophistication. It is worth striving for. Part of the reason I'm interested in making things simple is not because we got a simple code. It is because every step of the way, we develop skill to continuously make things simple. And it's that skill that matters in the long run. Today, it's hard. Tomorrow, it's a little bit easy. And 5 years from now, it gets easier. But it's a skill you take the time to develop. So it's not just the code you are making simple that's the end product. It's your skill that gets better every day is the more important byproduct of that. It's very well worth spending the time and effort fighting that battle to make things simple. I hope that was useful. Thank you. Enjoy the conference.